This is an HP8562B spectrum analyzer bought on a government auction site. No idea if it works or not. I bought it as sort of like spares repair. It's the B version of the version I've got, which is the A. This has a slightly updated electronics, and it's got a faster Motorola processor in it. I've had a look inside. I can see there's already some bits missing. Now the bits that are missing are the master oscillator, which isn't the end of the world, but there's also looks like a problem with the power supply. I plugged it in with a dim bulb, and even with the dim bulb it blew the fuse. I'm running on a dim bulb at the moment, but you can see it's drawing quite a lot of current and it's not even turned on, so I need to try and work out what's going on here, try and find out where all this current's going. So this will be the first video of seeing this thing's viable. It should be better than the A version, and it's also be a good backup. I've obviously had to find a crystal oscillator, which is a bit of a pain, but this should be a more responsive unit. It's got a much faster processor in it, and of course it's much newer as well, so it should be nice to have a unit that's probably a bit newer and going to be more reliable. That's of course if we get it going. So first of all, I'm going to try and track out where this current's going. It looks like it's drawing quite a lot of heavy current. So let's try and track this where this is all going, and try and fix the problem. Okay, let's check this regulator board. Regulator board, it's a rectifier board. So we're checking all these for diodes first. So we'll just go across each diode. One beep shows that it's got a voltage drop. Okay, clearly okay. Reverse the leads, no beep. Okay, so that tells us that the main... No, that's right, so I shorted something out. The main rectifier is okay. This thing, 2N6505, is a thyristor or silicon controlled rectifier, and it's usually anode-cathode gate. So across here there should be nothing, which there isn't, and this is basically the gate for the thyristor. They're also known as a crowbar circuit, and the idea is it's got probably a very basic voltage monitoring system here. As this is all linear regulator, if you get a pass transistor go short, what it will do is it will put a short circuit across the output to blow the fuse. Well, that's similar to what it's doing at the moment. It's drawing excessive current and blowing the fuse, but I expect the fuse on this board to have failed. So it could be that the 5 volts is unregulated and it's actually firing the crowbar. So if that's the case, what we need to next do is look at these pass transistors up here. These are the main regulator transistors. Check for collector emitter short. All these fuses have been checked, they seem okay, and of course we need to get these caps out and check them for a ESR, but also obviously check that one of those isn't short circuit. So let's turn the unit over, get the bottom of the board out and the top cover off, and so I can get access to the other side of these transistors, and we'll check for anything wrong there. Right, I think I've sussed out what was wrong with it. Nothing really. I don't know, I haven't tried it yet, but the bloody thing was set 115 volts. Now when I looked at the back inspection plate at work, it looked like the selector was on 240 volts, and I assumed that was right. So I'm going to power it up again and see what happens. I'm going to power up. So we obviously got the instrument check light on, which is normal because the thing's not connected up to anything, and we've got no internal reference. It's powered up, so let's just turn it off for a second. Okay, so despite me sort of saying how important it is to check the input support voltage, at least due to my shortcomings, the bulb has protected the unit from any overload. Also, the mains lead I'm using has only got a 2 amp fuse in it, so every time I switched it on, it just blew the fuses, which is great because it hides my incompetence. So you always check the supply voltages. We won't have done any damage. Basically, the regulator circuit would have just regulated it, but the transformer would have saturated before that and blown the fuse, so there's no risk of any damage to the unit. It might have been slightly different if we'd had an infinite amount of current in the mains. It might have damaged the transformer, it might have damaged the front end of the pre-regulator. So it seems like it's working. As I say, we've got no external internal reference oscillator. Now it's interesting, these units are supposed to have come from the UK, so I don't know if it's been abroad and come back, or it came over from the States. It doesn't look like it's ever had a lot of use. I think it has had some use. There was a bit of dust inside, but not a lot. And obviously the oven controlled oscillator's missing, the reference oscillator's missing. And I think that might have been taken out when someone possibly tried to plug it into the mains. It did exactly what it did to me just now, and they thought, oh, power supply's packed up, we'll use this one for spares. So what I'm going to do is I'm just going to pop these covers back in, because I think we're okay. Or shall I leave them off? No, I'll leave them off because I might need to check the capacitors at a later stage. So for the time being, I think the next thing to do is possibly connect up a external OCXO to it and see if we get any other lights come up. I don't want to connect it up to my display unit yet until I'm absolutely sure there's nothing else wrong with it. So I think possibly the thing is to power it up with an external oscillator. I could use the signal generator here, use the Marconi, that's good enough, and let's see if we get any sweep. Right, I've got the external input connected up from the Marconi signal generator, so it should have a reference now. Let's see if we get anything. Okay, I've got no control over any of the electronics. Let's do an instrument reset. Okay, we have got our error message light up, so I think the next thing to do is I'm going to need to check these supplies. I'm not going to keep this unit on for too long. This is our power supply. Just check our voltages, make sure everything's okay there. So just turn it off. I don't want it sitting there if it's all the voltages are wrong. I also need to keep an eye on those caps, make sure they don't get hot. Let's check a couple of these rails. Now I'm not sure this will actually work unless it's actually connected with a its actual video display, but I'm sure it should do something. So let's check a couple of these. This is the 5-volt rail here, and a couple of others. So let's put it on and see what we get. +5, 5.2. Oh, sorry, it's a -5, 5.2. That's okay. +5, 5.22. That's okay. +15. Spot on. +20. Spot on. Got a couple of other controlled voltages here. So the supply looks good. It could be just not sweeping, as I say, because it's not connected to its control unit, the other unit. So maybe the next thing to do is to increase our reference signal. So you can't see any error messages, obviously, because we've got no display. But it doesn't look like it's like none of the controls are actually doing anything. Instrument preset does actually reboot it. If I press instrument preset, let's move you away, but it's going to have to be handheld, I'm sorry. So the instrument preset does do a system reset. But this should select different inputs, and it's not. Likewise, none of these controls are working, so it's almost like the microprocessor side of it's not working at the moment. So I think we're going to have to connect it up to the other control unit and try it. Okay, this is the underside of the unit. I'm going to check these pass transistors for collector emitter shorts, and well, any short on them at all, obviously. So we're just going to quick run through these. So we basically don't want a constant tone across any of them, unless there's obviously a resistor or a current sense resistor across the collector emitter, which is not going to happen. So let's go through another check. That's okay, single beep, single beep. Okay, plus 12-volt regulator this is. A bit of black there actually. Bit of discoloration under that board. Might not be anything. Seems okay. It's a bit low, but it looks like it's charging capacitor up. So base to collector, base to emitter, yeah, base to the, yeah, base to collector, base to emitter. Is that a PMP? It'd be NPN, that one, so diode. That looks okay. I'm not sure that is discoloration or what it is. I'm just probably imagining it, but it looks like part of the board's possibly slightly discoloured underneath that transistor, which you can see that. Oh no, it's the writing. You see it's got this sort of dark area of writing here. It's the same there. I thought it was sort of discoloration. I thought something had blown up on the other side. Okay, so the next thing I'm going to do is we can find these capacitors, and these capacitors over here. They're easy enough to get through to. So what we could do there is we could actually supply voltage across them and see if anything's drawing excessive current. That'll prove to the point that the caps are, you know, they're not short. So let's put this. Now these are the capacitors that filter the rails, so they're like smoothing capacitors. So there's no harm in applying the voltage that they're supposed to supply anyway. So this 15 volt capacitor here, for example, you could probably put 20 volts in there, no problem, because there'll be a regulator after that. But we'll just try to hit its working voltage and make sure there's no excessive current being drawn, because if there is, and it's not the capacitor, it will at least tell us which rail is the problem. So what I'll do is I'll connect up my external bench supply, and we'll start on the 5 volt rail, and we'll set our current limit to about an amp. I think that's probably more than enough. Let's go half an amp, I think that's fine. Okay, so these leads have got 5 volts on them, so we need to find our 5 volt capacitor. And we do that by, because Hewlett Packard will very kindly give us a little plastic template to put over it. So we just need to get our polarities right. So these two on the left hand side are the 5 volt capacitors. One's the minus, one's the plus. I'm going to start on the plus because I would expect that possibly to be the problem. So the silver screw is the positive and the black screw is the negative. So I'm going to just connect that up. Now I think someone's been in here and checked these capacitors, but connected that up. And I've got no current draw at all, so there's clearly no short on the 5 volt. But of course there is another switch circuit that comes in after this to enable the supply, so we'll just go through. This is the oh, this looks like it's, oh yeah, it's supposed to have 10 volts on them apparently. That one, nothing, no short on that. This one, there's a small amount of current passing on that one. What voltage is that meant to be? That's the plus 15, so I'd expect that to, oh, it should have 25 on it. So let's increase that to at least 15 and see what that does. Yeah, it's not drawing anything excessive, a couple of 100 milliamps. And this last one down here is another, so that was a minus 15, I just checked, so this is the plus 15 in the corner here. Okay, no excessive current being drawn there either. Alright, so it looks at that point that there's nothing seriously wrong. So what I need to do now is possibly try and unload some of the circuit and power it up again and see what happens. So let's have a look, so we can do. Right, I've connected this RF set box to the display module. It comes up with a display, but there's no trace, so you get the graticule and all that sort of thing. That's all done by the main display anyway. So this isn't working. I have proved though that this unit you can control it, or my other unit, the A version, you can certainly control it without the front panel connected. without it connected to the video section. So at least I should be able to diagnose it out without connected up to the video display. Now we get the instrument check light on, which you'll get because it's not coupled to the other instrument. But we're also getting, it looks like a processor problem. You saw that when you press the instrument reset, it does obviously send a reset line, and it looks like it does a reset, but you can't control any of the controls, whereas you could on the A version. When I powered it up, you see these LEDs down here. This is the processor board. This is the later processor fitted to these, which is the Motorola 68000, similar processor used, or the same processor used in the Amiga 500. Power it up, I've got a stuck light on there, and I don't think that's right. So I need to investigate that. That's the fourth LED along. At the present time, I haven't actually got a circuit or a service manual for this RF unit. So, but it's right underneath this bloody ribbon cable here. So I'm gonna have to get this unit, this board out, and have a look. Maybe just check for insertion of the sockets and things, the chips, make sure they're all inserted properly. I've had this board out earlier on today. I cleaned up the contacts and put it back in, just to check when I was cleaning up inside, and it all looked fine. But let's get that board out and have a quick look. Okay, a couple of days later on, I've managed to find a manual on this 8568B. It's basically the same manual as the 8566B, which is the higher spec model, which goes to like 25 gigahertz or something ridiculous like that. There is a problem on this board, and this LED that lights, which is IO4, it's this LED here. The problem suggests that it's an input-output error or data bus error. We've got DS4 here that stays illuminated. It says use a signature analyzer or oscilloscope to isolate the fault. Unfortunately, it's not going to be easy, or it's not going to be cheap to do that, because this board uses 3 risers, and one of them is different pitch. You see, it's much finer riser pitch, so it's going to require buying 4 risers and trying to work out the exactly correct length to get the board mounted in the unit. So that's going to be a real bit of a pain in the bum to do that. What I have done, however, is I've borrowed a EEPROM reader from work, and I've read all the EEPROMs, and the EEPROMs are one of the things that could possibly be causing the problem, and it's the EEPROMs test OK. So what we're going through now is there's 2 options for this fault. Well, there's not 2 options, there's 2 things that they hint that it could be. Let me just try and find the page to show you where it is. Here we go. When the input-output failure is indicated by DS3 or DS4, which is the LEDs, or a combination of these LEDs remain on, it has become necessary to use an oscilloscope to find the stuck line or faulty component that can be located using a signature analyzer. Hint. Try replacing U20 and U42 PALs. They're a programmable array thingamajig, and they are these things and that thing there, and you cannot get those for love nor money. They're a chip that's burnt. Basically, they buy these chips and they burn in a sort of like a routing path or something. I don't know exactly how they work. The way someone told me is they sort of they burn in a sort of like a, I don't know, I don't totally understand it, but I think it's like a program into them. I don't think they're actually EEPROMs, but I think they're much more basic than that. But they're basically, these are unique. You know, you need this part number if you want to replace them. You can't go and buy the chip number and just plug it in because it hasn't been programmed. So they're a no-go, that you can't replace those, and that's the first thing it's recommending you check. The next things are the EEPROMs. The EEPROMs are easy to read when you've got the correct gear, and they test okay. We've done a long pop on here, and long pop is a power on, I think it's a power on protocol they call it. It's exactly the same as a power on self-test on a computer. You know, and remember the old computers when you used to power them up like the old 486s, and you could have a fast memory check where it just whizzed through and checked the memory and saw it was all there, or you could do the sort of long parity check where it goes through each bit to check everything's there. And basically that's what I've done. I've done the long pop, as they call it, and that hasn't revealed any more problems. Initially I thought maybe because it's an input-output error, it could be something to do with the GPIB controller. The GPIB controller is this chip here, and there's a couple of these chips down here. I don't think it's that. Now a lot of these chips you can actually get hold of. A lot of these sort of like standard dual inline chips. Most of these here, apart from these two here, we can get hold of. This is the RAM and the memory. So this is RAM chips here. I'm not too worried about those. We're not even getting to that point where it's getting that far, I don't think. So this is our yes, as I say, it's our GPIB controller and various interface buses. This is our sequencer, and the way they say they check the sequencer is working correctly is if all these lights go out together. Well, they don't. They go off in stages, so that suggests the sequencer is working correctly. And then you've just got a few bits and pieces here for running the backup battery. There's your Motorola processor chip here, and your oscillator, your master oscillator, and your battery that actually tests okay. Still got 3.6 volts on it, which is quite impressive considering it's a 1985 or something like that. And this switch is GPIB addresses and things like that. Plus this end switch is like a parity check. So basically, I think that this side of it's okay. There's something, one of these chips has blown up. Now what our option is to actually start changing some of these chips. Most of these chips are very cheap, and some of the chips I think I've actually got. But I was searching through eBay this afternoon, and came across another board, earlier style, because there's one in the States that someone wanted £270 for. I don't think they can really be serious about that, and there was no way I was going to spend that, because I spent sort of an eighth of that on the spectrum analyzer itself, so I'm not going to spend that sort of money on an old second-hand board. But I was looking again this afternoon and found, yes, as I say, an earlier board to this, and it was from Israel, and they wanted 25 quid for it. So that's on its way, and hopefully that will plug in that back in. This will get this thing working and clear this error message with this LED. But I would still like to sort of, I think what I'm going to still go through is try and work out why this has failed, because all the important bits seem to be okay. I think there's just a latch or something that's burnt out, and I'd like to try and fix it. The EEPROMs are okay. I think I might put those in the later board, because this has got 1987 date code on it, so it's these are probably much later ROMs than the ones I've got coming. These are standard UV EEPROMs, by the way. If you want to erase them, you just remove the sticker, and it exposes a little window in the top, and you bombard them in the UV for sort of like 10 minutes. That erases them, and then you burn them with the programmer that I've just showed you. So it's easy enough to reprogram them if you need to. So that's quite useful. So I'm looking around this area. I think we're basically saying that most of this is probably okay. It's all a bit of a guesswork at the moment, because I can't get the signature analyzer on here, because I can't get access to the boards, and as I say, it's just not worth me spending the money on the boards, to be honest with you. If I can get a replacement board for 40 quid, I'll try that, and let's hope that works. So yeah, let's wait for this new board to come, and maybe we can get some progression from there. Okay, here's the board out. And you see it's a little on the later versions. The older HP had a huge, great sort of chip here with a heatsink on it, and this is 5 years change in technology. This is the Motorola 68000. They run about 7 megahertz. There's your battery backup, which is originally done by a big battery pack on the A version. Now the LED that's stuck on is one of these I/O LEDs, so hopefully it's not an I/O chip's blown up or something, but it's that fourth chip was stuck on. So what I need to do is find a service manual for this board and actually have a look to see what it suggests. Now the only socketed chips are the ROMs here. The ROM lights don't fail, so I'm not going to mess about with those. So it does actually look initially like there's a problem with the I/O controller. This pinout header is actually a connector that goes to the back of the unit that allows you to connect to the video display, so that goes off to the video display, so we could actually run it without that to see what's going on. But as I say, it initially looks like there's probably a stuck bit or something, or maybe one of these chips here are packed up. Don't know until we have a closer look. So let's get it back into the unit so we can just verify is that LED. So I think it's first, second, third, fourth in from the end. Okay, to summarise, we've got a processor problem. We've got this LED on here, fourth one in from the middle. Can't find any information at all on this board. So I'm trying to track information down. This is the A15 board on the RF section, not on the top end section, not in the video section. I've got this LED stuck on. I've got no control over the processor at all. We should be able to change LEDs and get that to change state, but whatever I do, nothing, dead as a can of spam. So does the instrument reset? That clearly looks like a problem with the on-board processor. Now if I disconnect the external reference, because it hasn't got its own internal reference, you see we lose the lock light, so that looks like that's all working. That's good. But it's this board. I need the service manual for this board. Anyone knows if I can get an A15 service manual for an 8568B? That'd be great. Okay, it's back together again. Initially I thought it was the A15 processor board, and I replaced the processor board, but I managed to buy another one on eBay for a fairly reasonable price. Plugged that in, and exactly the same thing. Same LED stuck on DS14 saying there's a data bus error or input-output error. I did initially try the actual RF section on its own, and the bus just locked up like it did before, but what I didn't do was, when I had it connected up to this videos section, which is here, I didn't actually check the LED to see what the LED was still on. I knew I knew the machine wouldn't work, but I didn't know if the LED was still on, so I thought I'd check that. So I connected the display unit back up, and sure enough the front display didn't work, but the LED had gone out. So that suggested that the processor was actually okay, the main board was okay. Now this was running with my original board. So what I did then was I was thinking, well, maybe there's something to do with the controller board, the interface section, which basically interfaces with the front panel. So I pulled that out, and the light was still off, but it was exactly the same. I thought I was expected to see some more error messages or error lights on the processor or controller board, but there wasn't. But there's one chip on the corner of the board that's plugged into a socket, and I thought, well, I'll pull it out and put it back in and just make sure the socket's clean. Didn't really think an awful lot about it. So I plugged that in. Unplugged it, cleaned it up, plugged it back in. Now, bear in mind, I've had this board out before. It's not the first time the board's been out. Plugged it back in. Switched the unit on, and this time I got no LED. I had control over the front panel, which is the first time I've ever had that, and the display section showed a static non-sweeping trace. I couldn't get it to sweep. It wouldn't sweep. So I was sort of thinking, oh, I'm getting somewhere now. You know, it's progressing. So I thought, obviously, the only thing I can think of is that chip had a bad connection in its socket. I mean, it's certainly in there tight, but I took it out, cleaned all the pins up, and put it back in. So I thought, well, it's not sweeping. This is the sweep section down here, and this was all off with all the plastic covers taken off. And I'm thinking, I wonder if I got these two wires transposed, which I had taken off, and when I put them back on, I couldn't remember which way they which way they were connected. And at the time, it wasn't of much importance. I hadn't actually got the thing to actually have any control over the front panel or anything. So that was the least of my problems. I could have sorted that out at a later stage. So I swapped it over, and this is the result. Perfectly working 8568B. You can see the sweep lights working, flickering away there. Everything's working as it should. The only thing I'm still missing is the oven control crystal oscillator, made by a company called Oven Air. and I have actually got one from an 8662 that will fit, but I'll have to make some modifications because the board supply here with this little connector down the back here is only produces 18 volts, and the one from the 8662 has a supply for 12 volts, so I'd have to put a linear regulator in to reduce the voltage for the oscillator section. But it clearly works, and that's excellent because I'm going to replace it with the old 86 no, what is it? 8568A. So many numbers floating around my head. So I'm going to replace that unit. That uses the old HP processor. And one thing I did notice, and one thing that was where it used to really lag, was if you were using slow sweep speeds, it used to take a long time for it to be able to correct access. So if you're sort of trying to slow it right down, it would just sit there with an asterisk mark showing it was processing. I don't get that with this Motorola chip. So it's clearly an improvement on speed. And also this unit, to be honest with you, looking at it, I don't think it's had any use. I think this unit's been used as a spares unit. There's no doubt. There was a little. Yeah, I suppose it has had a bit of use because there's a bit of dust in the fan, but it's extremely clean. All the boards have been removed and everything's in really nice condition. So I think it's a very low hour unit. So I'm pretty pleased with that. You might be wondering why this is actually working, considering it's not working on an external. It hasn't got its internal OCXO. The Marconi is generating the 10 megahertz reference, and it's fed into the back of the unit at the moment. So all the time that's being fed in, the spectrum analyzer will work. But what I want to do is get the internal oscillator in, because it's self-contained. Then I don't have to have external oscillators running to it. I could connect it up to the rubidium, but one important factor about spectrum analyzers is that not only is the signal accurate, it is very pure. And though the rubidium is very, very accurate, it's not very pure. It's got lots of sort of noise and spurs and a bit of jitter and things like that. So it's not going to be an ideal source for a spectrum analyzer. It's great for a signal generator, but not so much for a spectrum analyzer. So yeah, it's up and running. Hopefully I'll probably have to buy an oven air oscillator in the States, get that installed, and let's get this thing finished off.